Hey guys, this is CHEMPLIFIED and today we will talk about the classification of organic compounds. Classification simply means characterization of organic compounds into different types. So without wasting time, let's start with the flow chart of classification of organic compounds. So this is the flow chart for classification or characterization of organic compounds into various kinds. First of all, organic compounds are divided into two categories: acyclic compounds and cyclic compounds. Acyclic compounds are further divided into saturated and unsaturated. On the other hand, cyclic compounds are divided into two types: homocyclic, heterocyclic. Homocyclic are then further divided into two parts: alicyclic and aromatic. Aromatic compounds are then further divided into two categories: benzenoid and non-benzenoid. So you can see that acyclic compounds are just saturated and unsaturated, or alkane, alkene, alkyne, that's it. These cyclic compounds have more characterization as compared to the acyclic compounds. Now we will look at each characterization individually and try to understand what kind of molecules comprise of which category. Alright, let's start with the first, organic compounds. Organic compounds are divided into acyclic and cyclic. Acyclic compounds or acyclic compounds are open chain hydrocarbon, right? Cyclic compounds are closed chain or ring compounds. Now cyclic compounds we will discuss in the next slide. In this we will only talk about acyclic compounds, which are characterized as saturated and unsaturated. So what is saturated? Saturated compounds are those that have only single bond or sigma bond, right? Saturated compounds are those that have only single bond or sigma bond. Example, all alkanes. What are unsaturated compounds? Compounds that have sigma plus pi bonding. Example, alkene bonding is like, right? Alkyne bonding is like. Understood? Whenever there is a presence of sigma and pi bond together, this will come under the category unsaturated hydrocarbons. Now we will move to the next, cyclic compounds, right? In the previous slide we left cyclic compounds alone. Now we will discuss cyclic compounds. What are cyclic compounds? Cyclic compounds are characterized into two categories: homocyclic and heterocyclic. What are homocyclic compounds? Ring formed by only carbon atoms, right? Ring formed by only carbon atoms. What are heterocyclic compounds? A ring formed by carbon and some other atom. What are those other atoms? Those can be oxygen, nitrogen, sulfur, phosphorus, right? And there are some other examples also. Now, homocyclic compounds are divided into two different categories, alicyclic and aromatic. Let's see what are these. Now, what are alicyclic? Alicyclic means cyclic compounds that are not aromatic. For example, these are some examples of alicyclic compounds. All right. It's a 5-membered ring of carbon. The other valencies are fulfilled by hydrogen. All right, like this. So all the valencies of carbon are fulfilled. Now, remember, alicyclic compounds can also have double bond present, can have double bond in it, but it should not be aromatic. Alicyclic compounds are cyclic compounds which are not aromatic in nature. That's it. All cyclic compounds with carbons in it can make alicyclic. Now, what are aromatic compounds? Aromatic compounds are those which are number 1 cyclic, number 2 planar, number 3 conjugated, and follow 4n plus 2 rule. Example, we are just taking one example. This is benzene. Now benzene is cyclic, yes. Planar, yes, it lies on the plane of the paper. It is conjugated, yes, double bond are in conjugation, and it also follow 4n plus 2 rule. So yes, it is aromatic. So aromatic compounds are cyclic, planar, conjugated, and also follow 4n plus 2 rule. Now, aromatic compounds are further divided into two categories. Let's talk about that also. Aromatic compounds are divided into two categories. Number 1 benzenoid and number 2 non-benzenoid. Now what are benzenoid? Benzenoid compounds are those that have one benzene ring, one or more benzene ring present. All right. Example, you can have benzene directly, right? Or right, you can also have compounds like this. These all are benzenoid compounds. Now what are non-benzenoid compounds? Now the definition of benzenoid is one or more benzene ring should be present. So in non-benzenoid, benzene ring is not present. So you can just write benzene ring is not present. All right. These are non-benzenoid compounds. Example, right? This is pyridine. Another example, one more, just like that. This is furan and this is thiophene. These are the example of non-benzenoid aromatic compounds. These all are aromatic in nature. All right, they all follow the 4 rules given in the previous slide. These are planar, cyclic, conjugated, and also follow 4n plus 2 rule. Alright. So this was the classification of organic compounds. I hope you understood. We will move on with the organic compounds in coming videos. Alright. This will be it for today's video. Thank you very much.